Hi, my name is Ron Dorn, and this video is a short overview of the Hawaii Physical Geography GPH 112 lab, the helicopter data tour. I'll start screen sharing here and just go over the lab from the perspective of me doing it and also explaining about it. I'm showing you an instructor screen of the Canvas lab, which basically is a presentation of what the quiz should look like for you. There's a pretty long introduction to this first lab because it's intended to link what we're doing in the games to the idea of science. So physical geography is a spatial science. We love to examine maps. We love looking at patterns in maps. And so the point of this introduction is to explain that we see patterns in maps like El Nino, for example, which is the first box here, and we try and come up with ideas to see if the explanations for our patterns are correct. See, scientists are not supposed to fall in love with the hypotheses or the explanation for the patterns. Our job is just to disprove them, because there's no such thing as a proof in science. If you know a scientist who says they prove something, they're not a scientist. All we can do is disprove things. And so I really like this graphic here that says science. If you don't make mistakes, you're doing it wrong. If you don't correct those mistakes, you're doing it really wrong. If you can't accept that you're mistaken, you're not doing it at all. So in a class like this, what we really want you to do is to practice science, to come up with an idea, to brainstorm about it, and to try and disprove it. So this lab in particular is designed for you to brainstorm. And so in all of the questions in this lab, we're going to start out providing you with some background information about one of the topics of physical geography, in this case on the Big Island of Hawaii. So the background information is that Kohala, the volcano here, is the oldest of the 5 large shield volcanoes. And the Hawaii shield volcanoes are all composed of the same rock type called basalt. And most of Kohala volcano was built over about a 1,000,000-year period. So the surfaces are quite old, a million years. And in the Hawaii geovisualization, so the second part of the lab is we want you to explore via helicopter. And so the idea is to do what I'm going to do here, which is to fast travel, go in the video game, go to fast travel to the Honoko Kaninui lookout. By clicking this box here, I fast travel to this lookout. So I'm going to hit escape and put it in a mode where my mouse or cursor can control what the rabbit is doing and seeing. And also by changing and messing around with the mouse, hopefully you got practice with this in the tutorial, I can pull the camera angle back and sort of see what I'm doing. So I pulled it way back out. In this case, I have a trackball and I'm changing the ring around it, but you just need to experiment with your mouse or your trackball or your trackpad, whatever you use. So I hit escape and that takes me out of the game mode and I can go back to the instructions. So I fast traveled to this lookout, and then my job is to take a helicopter across the island. And so this view here is what I want you to do. You're starting at this arrow, and I want you to use the inset map and fast travel to get to the other side of the Kohala volcano. So I'm going to go back into the game, click on fast travel, and look at this map in here, this inset map. A little blue circle is where the avatar is. I want to go to the other side. I click on this inset map, click, and then it populates the latitude and longitude. And so now I want to take a helicopter ride there. So I want to go as fast as I can. And I click on this box to go even faster. And I click Airlift. So it preserves the view of the helicopter and I'm flying over these deep valleys. And I'm clicking escape so I can change to rainfall. So I'm now looking at the rainfall map where the dark blue areas are the most rainfall. And then I'm looking at Landsat. So where there's lots of rainfall, there's lots of green, and you notice there's brown coming on the other side. So I'm going back to rainfall, and there's very dry conditions on the other side. and I'm going back to Landsat, and now I'm hitting escape so I can control the camera angle in the game. And what you'll notice is that there are no deep river valleys on this side of Kohala. It's very dry, and there's no deep river valleys. There is a gulch that you see there, but there's no deep river valleys. So the helicopter is going to dump the avatar. And if you have a kid helping you, the space bar will make the avatar drop. So just in case you want to go see that again, I can hit escape, go to fast travel, click on the Hanakanua lookout, and go there by airlift. Oh, it's taking me in the same helicopter ride again, because the pre-programmed points were already there. So that's the gist of it. I'm going to hit spacebar. Spacebar, drop the rabbit. And now I'm going to go back to the Canvas module. So the second thing is to explore, to examine the game, to look at the different layers, read the instructions. And then the third thing that you're supposed to do with this question is select a hypothesis to explain what you just saw on this helicopter ride. And I would love to have a class of 10 students where we could all just brainstorm synchronously. That's not the way this class is designed. We have hundreds of students in it because we want to give the experience to as many people as possible. So what I'm doing is I'm going to pop off the brainstorming explanations that these students gave. And that's really what the question is to examine these brainstorming questions. And the fourth component of all these questions is to give you a real scientific paper on this topic. So if you want to dig deep, this paper supports one of the hypotheses. So let's look at the question in detail. I'm going to try and blow it up here on the screen so you can see it bigger. What physical geography process is the most likely explanation for the much greater development of river valleys on the eastern side of the Kohala volcano than the western side? The answer that is keyed is correct is based upon the information you saw on the helicopter trip, looking at the Landsat image, the topography, and the rainfall. Keep in mind that we know that some students like to think out of the box. And this is one of the reasons for the appeal process explained in the syllabus. So if you decide to present your own out-of-the-box hypothesis, that's great, but you must then be prepared to send your instructor 2 paragraphs explaining why you think the evidence supports your hypothesis. You don't get to assert that you are correct. Assertions won't earn you the point. You have to take screenshots from the geovisualization and explain your thinking to your instructor. It's a way to do an essay to explain how you're thinking if you want that option. So that's this last one. I have another idea, and my plan is to select this answer and send an email appeal to the instructor. All right, so let's say you're not going to do that. You just want to move on. One option is, since the rainfall is pretty even on both sides, there has to be a different explanation than precipitation amounts. That's incorrect. You saw that in the helicopter ride. There's a lot more rainfall on the west-facing side of Kohala to get bigger streams and more stream erosion. Okay, wait, that's wrong. That's the opposite. So the only choice that's acceptable or close is there's a lot more rainfall on the east-facing side of Kohala to get the bigger streams and more stream erosion. If this question seemed on the easy side to you, that's great. If you're thinking that, is this a joke? Are all the questions in this particular lab going to be so easy? The answer is, I hope so. This is the first lab you're doing. The job here is not to stress you out, but to have you explore the data, get used to the geovisualization, for you to think about the ideas of the patterns you're seeing, and then to jump into the question and not stress about it. So there's a question about Kohala, a question about volcano types, where you flip and fly over Mauna Loa and Mauna Kea. There's a question about dew points that you see there's a question about something called plant succession, which is plants growing on a fresh lava flow. And then there's a question about examining lines in the game and matching them to a process. So I'm going to go here to this last one and have you see what I'm talking about. So there's 4 lines that you fly over in a helicopter and you match them to a process. So I'm going to take one of these lines that you see, Southwest Mauna Loa, starting location 1933. So I'm going to go to fast travel, and the starting location is 19.3350. And then the ending the longitude for the starting coordinates of this one is over here, and I jump to it. All right, so this is one end of the flight lines. And the ending coordinates that I program into fast travel is this one. I'm just copying and pasting. And pasting it into longitude. I hope you have a kid to help you because they can do that and you can take notes. I want to use the helicopter ride as fast as possible, and away we go. So we are on the southwest flank of Mauna Loa, and we're basically seeing a line. Do you notice that where the helicopter is flying, lava flow goes off of one side of the line and then the other side of the line? You're basically flying up the top over what's called a rift zone, where the volcano has a weakness and the lava moves up and flows down one side and then the other. This ridge, because lava just flows in the downhill direction, is the product of this rift zone. Lots of the Hawaiian Chia volcanoes have rift zones. So Southwest Mauna Loa, and the process that explains that line that you see is a volcanic rift zone with basalt flows, the dark black basalt flows. The southwestern arm of Mauna Loa is a volcanic rift zone, which is a weakness in the shield volcano, allowing magma to emerge in this rifting area. Hence, lava flows start at the rift and flow downward. So this is a longer explanation. What you see in Canvas is this one, a volcanic rift zone with basalt flows. You'll notice that there's another rift zone choice, but this one's dominated by cinder cones. And there's another choice about forests and another one about faults. So the idea here is to realize that in this question, lines do occur, although they're not very common in physical geography. And this is just exploring 4 different types of lines you see on the Big Island and connecting them to a process. The idea is that this is not difficult, that it should be hopefully obvious if you just go through the steps, and also, most importantly, interesting. I'm going to stop this presentation because I think you're good to go on your own on this one. And I hope that this presentation just relaxed you about this lab, and I'll do hopefully similar presentations that will relax you hopefully for the other labs.